Okay, so let's take a look at some of the other laminations within the boat. We did the transom in the last video, and in this video we're going to take a look at the stringers and the stem for the boat. The stringer jig is what I've got in front of me here, so let's take a look at that first. So here we have the giant stringer jigs that are going to form two big beams that run through the centre of the boat, tying pretty much all of the frames together. These form the engine bearers and also the supports for the sole boards, and just generally induce a huge amount of stiffness throughout the boat. So they're pretty big, and this is what the jig looks like. So I do pretty much all of my lamination jigs the same way. We've got these little cutouts in here for clamps. Obviously these are tiny, so I'm not going to be able to get clamps in there, but you will be able to on the full-size boat. And they join together with a little CNC cut dovetail system that slots together. Now all of the jigs within this boat are made up of 2 layers. And there's a couple of reasons for that. One of them, it helps to form a more rigid jig, but also it allows me to be able to stagger these joints so that we can put the two together. So you can see there's a little joint within there, but then the joint on the second layer falls halfway down through that. So all of these are spanned, and it just gives an extra bit of reinforcement to that dovetail joint. These are going to be under quite a bit of stress actually when we put the full lamination together. It's a big piece of timber, especially on the full-size boat, so these have got to withstand a fair bit of force. And we'll take a look at the stem lamination jig after this one, but you can see again same process. So the stem lamination jig joins in the center there, and then we've got 3 parts for the second layer, and one of the layers is marked, so we'll use all of these marks and frame numbers for reference when we start to take positionings off the stringers when we put them into place. So the first thing we're going to do is to get that built. So I've put the first side together. I've just dry fit this, and I think similar kind of scenario to the transom jig that we did in the video before. These are actually so tight fit in these joints that I won't bother to glue them, but I will glue the 2 parts together so that we can stick them together and get a nice rigid jig. So the jigs can either be stuck directly together, or you can put a slight spacer in between the middle of them, which you can just see illustrated in the drawing there. And that's if you just want to part these open a little bit so that they touch either side of the lamination. So this is just a scrap off cut of the size of timber that we're going to be laminating, and you can see that actually I'm not too bad on the width for that. So you can just pack these out slightly if you want a little bit more thickness there, just to make sure that you've got good contact on either edge of the lamination, which will certainly help to get you a nice clean edge when you glue up. Now all of the laminations are sized oversized, so you can see up there that we give a width of 44mm, and that is the finished size of that lamination. Same thing with the stem, that's shown as 76mm. But if we take a look at the timber cutting list, you'll see that these are slightly different. So stringer laminations 50mm, and stem laminations 100mm. So what that allows you for is cleanup of the lamination once the epoxy's dried. So same kind of process as we had with the transom here. You're going to get slippage between layers, and slight misalignments, or just generally a kind of unclean edge when you glue these up. So I always do laminations this way, cut them oversized, machine them down, and you get a really nice clean finish to the lamination. So yeah, I account for a bit of that within the plans. If you're a little bit concerned about some movement, or you want to make sure that it's super clean, just make these a little bit wider. I mean, you've got plenty within the stem, 100mm wide, and then you've got to get down to 76. The stringers are probably a little bit narrower, so you've got 6mm there to machine off, which is generally what we'd allow to machine a timber board from sawn down to a plain finish, around about 6mm off the dimension. So that's what I've allowed for there. So first thing I'm going to do is get that jig put together. I'm going to glue the second layer to the first layer, and then we'll have a full thickness jig ready to go. Okay, so you want to make sure that you leave the engravings on the outside. We're definitely going to need to have them visible, so I'm going to flip this over and then start to glue my parts back on. The clamp holes will align between layers, so that's a really good feature to help you make sure that these are perfectly aligned. when gluing up individual layers. Okay, stringer jig done. So those two layers are glued together and you can see we've got a nicely staggered joint there between each of the parts. Now lamination thicknesses are, in all honesty, I've just really taken a pop at these thicknesses when putting the plans together. What you're going to need to do when it comes to actually building this boat is to get a piece of stock, whatever you're using for the stringers, and just try and see how it's going to make the bend. So I've put in 12mm thickness or 1/2 inch thickness stock for the stringer laminations, and you can see that indicated in the laminations there. The opposing colours are really just to make things a little bit clearer, so they should be mahogany all the way through. The opposing colours just help you to count the laminations and see what's going on in each of the scenarios and give an indication of the thickness as well. But as I say, you should take a little bit of interpretation on this based on what stock you're using. So 12mm in theory for quarter scale would work out a 3mm thickness, but what I'm actually doing here is I'm going for 6mm because I've found that it will quite happily make the bend. Now I wouldn't want to go much thicker than that because they're going to start to get quite a bit of spring back and I'm inducing a little bit too much force into the lamination if I go any thicker. So play around with things when it comes to what stock you're using and what you're doing. As a general rule of thumb, based on the Goujon Brothers method, we don't go above 25mm thickness in any timber within the boat building process. Anything that needs to be above 25mm then needs to go to a laminated piece of timber. And that is to keep us nice and dimensionally stable and strong and exactly what we want. So not above 25mm, you could probably go up, you may be able to go up to sort of 20-25mm with these on the full boat, but as I say, give it a try. Depends on the stock you're using, how it wants to take the bend. I wouldn't advise steaming timbers or going too thick. Find something that will comfortably make the bend cold and laminate well. So with that said, off to the wood rack, let's get some timber made up for building a stringer. Okay, so I have my stock laminations cut. You will notice with the Temptress stringer that there is an additional thickness to the aft section of the stringer. So this runs from frame 9, I think it is. This forms an increased strength within the boat where in the area of the engine. So from the frame 9 bulkhead aft, and that creates this little step in the stringer, which you can see in the jig here. And what I've done is I've sized my first 3 laminations to match that step. So if you look very closely at the drawing, you'll notice that there is actually a slight taper to those first 3 laminations. Now where that taper is taken up, whether it's in these 3 or whether it's taken up in these outer layers, doesn't really make a huge amount of difference really, because all of that will get altered as we bevel the stringers down to match the framing once it's all installed on the boat. So to make things easier, what I'm actually going to do is glue up those first 3 layers as an individual assembly, because what I want to do is get this forward edge here really nice and clean, and that's going to be a lot easier to do if I can just pop that on the chop saw or on the bench and just reface that edge. So first thing I'm going to do is glue up those 3 layers, and then we'll clean that up, and then we'll glue up the next set of laminations over the top of it, so you can see we'll form that edge really nicely and spring it into place. So let's get started with that one. Okay, so as I've mentioned before in the previous videos, I'm using different glues with the model just so that I can get through things and show you guys the general process nice and quickly. You definitely want to be using an epoxy for this, and following the procedures that we looked at with the transom, where we wet out each face of the lamination, use a notched spreader to apply the epoxy, and then put the whole assembly together. In this instance, I would highly recommend wrapping all of these laminations in a piece of polythene. When I've done laminations like this before, I would lay some polythene out on the table, glue up all of the laminations, and then roll them up inside that polythene, then put them onto the jig, and then clamp them into place. So the polythene is a really great way to be able to keep your bench clean, glue up all your laminations, wrap it all up, and then once you've done that, you can actually take your gloves off and you're just handling a nice clean part that you can then load into your jig and get into place nice and cleanly. And that's quite a challenge at times when you're using epoxy. I can't really do that process with Titebond because Titebond will not cure properly if it's absent from access to the air. If I wrap this in polythene, it's not going to cure properly. But obviously epoxy is a chemical curing reaction, so it dries fine even when it's completely wrapped in plastic, and that's the reason we can use it for vacuum bagging and things such as that. So I'm going to have to do this a little bit more of a messy way, but we should be okay anyway. Okay, so there's the first stepped part of the lamination glued up. You can see we've got that little gap just in there, so what we're going to do is let that dry, and then we'll trim up this end just to match that angle into frame 9. We'll shift that slightly further forward, and then we'll glue up the second part of the lamination on top of that. Okay, so the stem jig is assembled now, and it's much the same scenario as the stringer jig. We've got the same overlapping dovetail joints. You can see that I've just decided to space these two, the two parts of the jig in this instance, because the stem laminations are a little bit wider, so these are working out at 25mm quarter scale. I wanted to get those a little bit wider just so that we've got good even support of the laminations. The other thing of course you can do is just cut more of these parts. If you wanted a solid jig that was right the way through and give even more support to the laminations, you can just cut more of these and increase the amount of layers you've got. But I've packed this for now, and you can see that the little packers I've put in place just bridge the point at which there is a dovetail joint. And that just helps to transmit that strength through all the parts. So we've got the laminations cut as well for the stem, and the laminations that I've gone for are 1.5 mil. So that's actually a little under size. I recommended 8 mil for the laminations on this, and that would technically take me to 2 mil, but I've gone to 1.5 because I just did a little test, and the 1.5 mil bent nicely around this curve, so I did that. If you've got to change lamination thicknesses, basically all you're going to need to do is just to look at your timber cutting list. So you can see here it says stem laminations 8 mil thick, 15 of those. So you can work out the total thickness of that lamination by multiplying 8 by 15, and then just divide that back down by whatever thickness you decide to use, and that will give you the thickness that you need for your total lamination. So I'm going to do a dry fit of those and just check that they're happy making the curve, and we'll trim them to length as well. So we've got plenty of length here at the moment to get around there. So we'll get those sprung into place and see what it looks like. So I'm going to start by lining all these up just at one end, and then you can see on the jig here that we've got various different marking points. So the trim line is where we're actually going to cut this lamination down to once we've finished the glue up. So we want to make sure that there's plenty of overlap on there, and you can see that on some of these laminations I've got a little bit of snipe in the end of the material where it's going to be a bit gappy from where it's been machined, so I want to lose that, and I'll start the lamination beyond that point. So we'll get a clamp into that, and then you want to support these laminations quite nicely as they go around. You don't want to just start pulling it from this end and bending them into position. You're highly likely to get breakout on this back edge here. So we're just going to ease them into place and add a clamp as we go around the curve. So there we go, our initial dry fit of the stem lamination. You can see we've got masses of material here, and we don't want to be wasting glue gluing that up. So what I'm going to do is just roughly mark some trim lines for now. We still want to keep it oversized to give us plenty of room for slippage or anything like that. And you can see that little bit of snipe just in those few boards there. So we'll lose that within our trim line, but I'm going to keep that end as it is. So we're about ready for glue up actually. So I'll take that back apart, we'll get those laminations glued up, and then we'll spring them into place. So you can see we've got a difference in length in those laminations there as they sprung back out. So we want to make sure that we keep these in order so that we don't mess that up and end up short down one end of the lamination. So I'm going to just keep those like that and then just fold them over and glue them one at a time and stack them up. So, stringer lamination glued up. Sponsored by Irwin Clamps, as you can see. I'm just kidding, I buy all my own clamps, I'm not sponsored by them. But you can never have enough of them. So, there we go. You're going to want quite a few clamps if you're doing this on the full-size boat. Probably, realistically, 1 clamp per hole that I've got in the jig there, I would think. So, there we go. There's the first of the big stringers done. So we're going to want 2 of those in total. I'm just going to do 1 now and show you the process. So we've got the stem done, letting that dry, and 1 big stringer. So I'll revisit those tomorrow once the glue's dried up. We'll clean them up and then we'll take a look at what else we do with the jigs. Okay, so we've got the laminations out of the jigs. 1 giant stringer piece, as you can see, and 1 stem as well. Incredibly tough lamination, that is. So many fine layers in that. That is a really strong piece of timber, and this is just on the model. So on a full-size boat, that is going to be quite a colossal piece of timber. So if you're cleaning up these parts on the full-size boat, obviously this stringer in particular is going to be a massive timber. It's going to be probably 20 foot long and probably a 2-man job, I would think, to lift it. So you want to probably clean this up with bench planes or electric planer or electric belt sander, something like that. It's not really going to be feasible to get that through a machine of any sorts, I would think. The same with the stem. I would imagine that's going to have to be done like that. I typically do laminations like this if they're a manageable size. I'll do them on the bench jointer. So I'll run them through the surface planer and get me 1 really flat face, and then I'll run them through the sander or through the planer to clean up the second face. We'll run them through the machines downstairs and get these nice and clean and down to size as well. So remember, we're over thickness at the moment on the width of these, which gives us plenty of scope to clean up all these edges, get rid of the glue, get a really nice clean looking part. So let's shoot down into the shop and do that. Okay, so 2 very nice and clean, very flat laminations. So string in there, and then our stem as well. So we've got those down to the correct width. So there is another function to these jigs, as well as just forming the laminations that we've already done. These actually now serve as a marking guide for everything that we're going to need to take off of these various different parts to align things when it comes to the actual boat building process and assembling the entire boat. So what we do is we then put the lamination back into the jig that we've used to create it, and just going to find the point at which that wants to sit nicely, and then just nip it there with a couple of clamps. So then once that's in place, what we're going to do is transpose all of these marking lines onto the stem, because we'll need them further down the line. So we've got a trim line at the forward end there. We've got the top of our chine. And then our frames. Then I'm just going to square those lines around the stems so that we've got them on all sides. So there you can see all of our marking lines. Around each face of the stem parts. Okay, now the stuff outside of the trim line can be cut off, so we're going to mark that as scrap. And then we can neatly trim up the end of our stem lamination. Okay, so once we've transposed all of the lines from the lamination jig onto the stem, it has one final purpose. We're not finished with it just yet. And that purpose is going to be to position the stem within the strongback. We had a little glimpse of that in the strongback setup video. So what we're actually going to do now is to cut down the jig, and that will then become our alignment system to put the stem into the boat. So the lamination jig gets cut on the line of frame 1, and then that's going to fit up against frame 1 in the boat assembly. So we'll mark the frame 1 line all the way around the jig, and then we'll trim it down to suit that. Okay, so the stem jig is cut down, and we can then reposition that within this lamination, line it back up using our trim line mark and our chine top mark, and we're just going to pin that in place and then position it in the boat. That's pretty nice, isn't it? Okay, so we can see that what happens here is that the stem lamination jig then positions our stem on our forward rung on the strongback, and all of this hasn't been set up perfectly yet. We haven't yet set the correct heights on the frames with the waterline 1 mark, but we'll do that a little bit further down the line when we do a full boat setup. So then we'll also set up the waterline 1 on the stem, which will position this in its correct height. But you can see here how the lines will transpose, and just double check that everything fits against our frames. And what we're going to have to do is to bevel the notches for these various different frames, just to seat that stem right down in its correct final position. But that's a basic premise of how that works. So we'll look into that a little bit more detail when we do a full setup of the boat and we start to actually install a load of these components that we're making. So the stringers are much the same deal. We're just going to transpose all of these lines from the lamination jig onto the stringers, and these just give us the positions of each frame throughout the boat. So that's going to be a double check backup for our strongback. It's also going to be a longitudinal position for the frames on the sort of the boat's upside down but bottom end of the boat, and the strongback obviously takes care of the top end of the boat. So with the two together, it should make sure that everything squares up really nicely, and we know that we can notch these stringers in just the right place. So it's a sort of cover all bases double factor thing really. So I'm going to transpose all of those lines across to the parts of the stringer, and I'll trim down the ends. I might, just as a extra precaution measure, I might just leave a bit of extra material on the transom sticking out, because it wouldn't hurt to just have that. It's actually notched through the transom framing, so we can stick it right out through the transom framing, and then do the final trim just before we go to put the skin on the transom. So I think I'll do that. The forward end actually terminates at frame 2, and I think it terminates on the aft end of frame 2. Yeah, frame 2 it goes through the bulkhead, but it doesn't go through the framing. So I'll nip those back into the jig just with a couple of clamps to make sure that I don't get any movement whilst I'm doing the markup, and then we'll take a look at it afterwards. So there we go, string is marked up for each of the frame positions. That's going to really help us to get everything in line when it comes to installing those in the boat. We'll do a big dry fit of everything. Forward ends trimmed up to terminate at frame 2, which you can see it does just there. And then the aft end, which is going to come through the transom, so I've just left that oversized. That's the actual trim line that we should be finishing at there, but I've just left a bit of material because the transom's curved, so that's probably going to have to be cut on an angle, that, so it doesn't hurt to leave a bit of material there. So there we go, that is as far as we're going to go with this video. We're slowly getting more and more of the components of the boat built and ready to actually stick some bits together and start assembling things. So I'm going to get the other stringer. There's going to be another one of those, which is just a carbon copy of that. So I'll make the second stringer up. I've got a couple more frames to do. So probably in the next video, I think we're going to start to look at how we actually fettle some of these parts to do the various different bevels and things on them and get them starting to fit into place. There's a handful of things we've got to do, and there's going to be a load of dry fit stages just to make sure that everything fits and locates properly. We'll do a full setup of the strongback with the laser level and get all of the frames at the correct height and properly positioned. So yeah, we'll slowly start putting things together. So hope you enjoyed the video, and I'll catch you in the next one. Cheers guys.